Hello everyone, myself Dibakar and I graduated from Ramakrishna Mission Vivekananda Centenary College, Raura, Kolkata. In JAM, I secured All India rank 143 and in JEST, All India rank 34. I also qualified TIFR GS examination. And in previous video, I'll share my interview experience at TIFR Mumbai. And now in this video, I'll share you my written examination experience at TIFR. So in this examination, there are 6 questions and we have to answer 5 of them. Total marks is 50. One question contains 10 marks and all the questions have some part marking like 2 plus 2 plus 3 like this. And in any question, if you actually not obtain this exact result, but your method is quite logical and right, then you will get partial marking for that. So I can here the question नहीं दिया है. So in the first question, it is from mathematical physics. That is, I have to solve this integral equation, that is 0 to omega dx 0 to x dz yz equal to y w. So to solve this, we have to use the Leibniz theorem for differential under the sign of integral. So we have to differentiate it first with respect to w. And here it is just y prime, and then after doing this integration we get 1 multiplied by 0 to w dz yz equal to y prime w. Actually, according to this rule, if ddx of some function which is called phi x, psi x, f of x, comma t dt, then this is give out so by applying this rule we get it like this, and then again differentiate it with respect to w. So now the auxiliary equation is x square equal to 1 so the general solution is y equal to some constant a multiplied by e to the power minus omega plus b into e to the power omega. So this is the solution. In second part of that question, we have to find the length of a curve, that is y equal to x square plus 2, where x is varied from 0 to 1. So x is varied from 0 to 1, and the length of this curve, that here the curve is look like this. So from x equal to 0 to 1, that means the length of this curve we have to find out it. Now if I see a small portion of this curve, then I can see that this dx dy and this small length of this curve is say ds. So ds equal to root over dx square plus dy square and 1 plus dy this. Now the length of this whole curve is simply s equal to 1 plus dy dx square dx, x limit from 0 to 1. Now dy dx equal to 2x, so put this value here, get it 1 plus 2x whole square dx. Now 0 to 1 to 1 by 2 square plus x square. And then applying this formula for this integration, we get it's 2 times x by 2 root over x square plus 1 by 4 plus 1 by 8 ln x plus root over x square 1 by 4 0 to 1, and then after calculating this we get 1.47885. So this is the value, this is the length of this curve. And then one question is like this, that this is x-axis, this is y-axis. A non-relativistic charged particle which have mass m and charge minus q, where q is greater than 0, is moving anticlockwise in presence of a uniform constant magnetic field B vector which is along the z direction. So in the z direction we have a magnetic field B vector and a charged particle of mass m and minus q charge is moving. So the motion of this particle is found to be circular in xy plane, shown as in the figure. So we take the origin of this axis at the center of this circle O, and the radius of the circle is given, which is r. Then write down the trajectory of the particle, like this is the trajectory which is a function of time. So I have to find this thing. Now from here we can see that mv square by r equal to b q into v, and then v equal to b q r by m. So that's the thing. Now at any time t, let's say that the particle is in here, so this is angle theta, where theta equal to omega t after t time, and the velocity is along that direction. So it has two components. One is in that direction, another is this. This is the Vx and this is Vy and this is the V. Now this V has the value this, and I have to find this Vx and Vy. Now if this angle is theta, then this angle will also be theta. So Vx is equal to V minus V sin theta, as it is in negative x direction, so it is minus V sin theta. And then here it is B Q R by M sin omega t equal to dx by dt, and after integrating this we get x equal to V Q R M, so there is a minus sign, omega minus cos omega t, and it lead to what? So omega equal to V by R equal to BQ by M. So this omega and this BQM will cancel out and left just R cos omega t. So this is the x as a function of time. Similarly, we have to calculate y. So V of y equal to B cos omega t, and then after doing similar calculation we get it's R sin omega t. So the answer of the first question, that is the trajectory, is something like R cos omega t comma R sin omega t. So this is the answer. Now in the next part of that question, a constant electric field E vector is introduced along the x-axis. Now in this direction a constant electric field is applied, and the particle is at y equal to 0, and at p point you can take this is as reference time at t equal to 0 for the next part. And now write down the expression for x dot. So now what is that? What is this? I have to find out this two quantity. Now for that, this electric field is along the x direction, so it has no component, and so the charged particle don't feel any force along the y direction, it only feel force along x direction due to this external electric field. So along y direction the y remains same as previously we calculated, that y r sin theta, so sin omega t. So y dot is simply r omega cos omega t. So this is y dot. And now for the x dot, this is the total force along the x-axis. This is due to this electric field, that is minus q times E, because the charge is negative, plus the previous force due to this magnetic field, that is m times x double dot. So then it is d2x, then it is x dot equal to minus QE t by m. After integrating one time this is, and actually this x dot is the previous x, so these two things are different. So the value of this is x dot, the x is simply r cos omega t, so it is r, here is a minus sign, m r omega sin omega t. So this is our new x dot after applied this electric field. So this is the x dot and this is the y dot, and so the answer is here. And then he asked me to write down the subsequent two-dimensional trajectory of the particle in terms of m, q, b, e and r. So that means they asked me to write now the new x and new y as a function of time. So it's just the integral of this. After doing the integration, you get this is like QE t square by 2 m plus m r cos omega t, and then here it is y equal to r sin omega t. So these are the result. Now in next question, one-dimensional chain that has component of this chain chain segment, which is a large number, that is much greater than 1. So shown in the figure, and the figure is something like this. Kind of this, one is vertical and another is horizontal, like this. So each segment can be in any two state, horizontal or vertical, with both of them being non-degenerated. Let the length of this each segment be a. So the length of this segment is a when the horizontal, and 0 when it's vertical. So when it is horizontal then it's a, and when it's vertical the length is 0. So the energy associated with horizontal segment is Fa. So here it is Fa, and here this energy of the vertical segment is 0, and the temperature of the system is T, and ignore gravity. So first of all, write down the partition function of the chain. So we know that the partition function is something like this, and then e to the power 0 plus e to the power minus beta Fa equal to 1 plus e to the power minus beta Fa. So this is the partition function. And then ask me to calculate the free energy Fe equal to minus kB T ln Z. So this is just this quantity. This is the free energy, and then entropy. So for entropy, we know this. So just try to calculate this. Del T times minus kBT ln 1 plus e to the power minus Fa by kT. So for that, this will be plus, and then kb ln 1 plus e to the power minus a by kt plus kbt 1 plus e to the power minus a by kt into e to the power minus fa by kt times plus fa by kt square. So this is the answer. This is the entropy of that system. And then write down the expression for mean length of the chain. So the mean length of the chain, which is like this, is just this is, and the length for horizontal is a, and for vertical it's 0. So it is so this is the mean length of that chain. Now what is the equilibrium? What is the equilibrium mean length when the tension F is 0? So at equilibrium, when F is 0, this led to you A divided by 1 plus e to the power 0 equal to A by. So this is the length of this chain, mean length of this chain at equilibrium when F equal to 0. So then there is another question, that is, what is the spring constant of the system for a small deformation near the equilibrium length when F is very small? So actually I can't do this at that time. So let's move on into the another question, that is, if a volume of an ideal gas is kept constant and its temperature is T, increasing linearly with pressure given at T equal to A times some constant B into P. P is the pressure, A and B are two constant. A and B are two parameter. For an experiment, we get the data for the point P and T are listed in the table. So find the best estimated parameter B, determine the temperature when the pressure drops to 0. So basically there is a table of T and P, and we have to find the value of A and B. So by doing so, this is the P and this is the T, and it have some unit given mentioned here. And P is in mmHg and this is in degree centigrade. Now if I draw a curve T and P, then in this curve this B is a slope and A is intercept. Now for B, this is the dt dp. So from this data we get many value of B, and then we'll take average of this value of B and we get a most accurate value of B. So first of all, B1 is 17 minus 23 divided by 75 minus 65. B2 is similarly 52 minus 17 by 85 minus 75, and this will give another result. So after calculating this value, we get it as 4 degree centigrade per millimeter Hg, and then 3.5. Similarly, B3 we get 4.2, and B4 we get 3.6. So the average values of these, that means this plus this plus this plus this divided by 4, will give you 3.825 degree centigrade per millimeter Hg. So this is the value of B, and now I have to find the value of A. So now we get this. We have now the slope, and for given slope and a given one point, we get a straight line, and we can calculate the intercept of this. So for each point we get a value of A, and after that I have to take average of all this A, and then I get the value. So A1 is T minus BP, so T is minus 23 minus BP, that means 3.825 times 65. A2, A3, A4, A5. So here we get minus 271.625 degrees centigrade. This is minus 269.875, minus 273.125, and after getting this result and after taking the average, we get the value of A as minus 271.125 degrees centigrade. So this is the answer. After that, there is another question that a closed cylinder of radius r and height h contain an ideal gas at constant temperature T. The cylinder and the gas as a whole rotated about the cylinder's axis with an angular velocity omega. Assume that kinetic energy when the rotation of this gas molecule is much less than their thermal energy, and also ignore the gravity. For omega equal to 0, first question, for omega equal to 0, if the mass density of the gas is rho naught. So this is the mass density, that means the total mass by the volume of the cylinder, that is pi r square times h. Then determine the total number of molecules and the pressure of the gas on the wall of the cylinder. So first of all, I have to calculate the total number of molecules. So the total mass is the total number of molecule n times m divided by pi r square h. So m equal to rho naught pi r square h by m, because here the small m is given, the mass of a single molecule, and these all are given. So this is the total number of molecule which is contained with this container. And then they are asked that to find the pressure on the wall. So as it is a ideal gas, so PV equal to NKT. So pressure equal to NKT by V. Now N means rho naught times V by M times KT by V. So rho naught KT by M. This is the pressure. And if it rotates with an angular velocity omega, then we have to calculate the mass density rho r and find the expression of del rho del r at r distance from the axis of this cylinder. So I don't do this problem in the examination. And then there is another question that what is the value of this ratio, that is rho of 0 by rho naught along the axis of the cylinder. Is it greater or less than 1? What is the physical interpretation? So it is when there is no angular velocity, that is the rho, and after getting this angular velocity, the gas particle will move toward the surface of the cylinder due to the centrifugal force. So that's why this is must be lesser than 1, and the physical interpretation is something like this, that due to the centrifugal acceleration the gas particle move toward the surface of this cylinder. And then calculate the distance from the axis. Is the density of this gas remain unchanged by the rotation? So if we calculate this rho of r, then at which r this rho of r is equal to the previous rho naught. So you have to calculate this. So this we are not done in the examination. So these are the 5 questions, and there is another question which is on quantum mechanics. So thank you for these are the whole written examination experience at TIFR Mumbai. Thank you.